where my knowledge gaps are not as pronounced as perhaps in other areas. So really, I think I'll just get on with just the liver. And with this talk, I think I just want to perhaps look at the functional aspect of the liver aspects, and perhaps mostly like the structure, and perhaps the histology. Not really like in terms of a lot of histology. Perhaps I should have just said the structural, the functional aspects really, as in the structure of the liver. Anyway, the liver is the largest organ in the body. Just a quick review. Organ in the body. I think it's approximately 1.2 to 1.6 kilograms in a normal human being. It's located on the right upper quadrant. It also covers a bit of the epigastrium, and indeed some of the a section of the left lobe is also located on the left upper quadrant. So if I was to borrow my model, so really it lies under the diaphragm. So the diaphragm will be there extending over. This is the abdominal cavity, and really it will lie here. I thought I was sneeze. And it will lie on the under the dome of the diaphragm. It actually has a reflection of the diaphragm, so it lies under the dome of the diaphragm, an impression of the diaphragm. I don't know why I say reflection, impression of the diaphragm, and then it lies on the right upper quadrant, a little bit on the epigastrium, and some of it lies on the left upper quadrant as well. And so I don't think I'll make the model, but I'll just leave it there. So it is located there, and really it lies under the dome of the diaphragm. And it rests on the stomach, particularly the stomach and the intestines, the right kidney, and the obviously adrenal gland, which lies on top of the kidney. So it has the impression of the stomach, the intestines. This is the hepatic flexure, and it has the impression of the right kidney and the adrenal gland on its visceral side. So really, since I've mentioned the visceral side, I might as well as really say it has faces, like faces or sides. It has an anterior aspect, which is what we see. So if I were to borrow the model once again, so if we were to look anteriorly, if we were to look at someone who's if we were to look on the anterior surface of someone, what we'll see is the anterior aspect of the liver, which is actually smooth, and well, actually the liver itself is covered in a very tough capsule, which is called the capsule of Gizzard. So it will have the anterior aspect, and then it will have the superior aspect, which absolutely lies under the dome of the diaphragm. Then it will have the posterior aspect, and indeed the inferior aspect. So that's really important to know that it will have faces. The inferior aspect really is the visceral aspect, which rests on the GI organs, and indeed the urinary tract organs. So it has the anterior aspect, which is what we see if we were to dissect, make a midline section, open up someone. What we'll see facing us will be the anterior aspect. And then it also has a visceral, well, a superior aspect, which lies under the diaphragm. And then, important, it has a visceral aspect, which rests on the GI organs, the stomach, the intestines, and GI organs, and kidney, and adrenal gland of the kidney. So really, again, on the visceral aspect, it has the impressions of the organs that it rests on, and that really makes it easy. So the liver is divided. So it's divided into the right and left lobes, and those divisions on the anterior aspect is formed by the falciform ligament, and then on the posterior aspect, really, which is more like the visceral aspect, it's via the teres ligament inferiorly, and the ligamentum venosum. Again, these are the remnants of the, from the embryo. So when I say inferiorly, and this will be superiorly, what I mean really, say if we were to imagine the liver as an oblong of some sort, and this is the right and left aspect, we would see that anteriorly the falciform ligament will run like that. And really, another important aspect really is that the superior aspect is also sort of divided by the falciform ligament, in the sense that the falciform ligament extends to the superior aspect. So if this was the superior aspect, like that, so the falciform ligament will extend there and form the triangular ligament on the left side, and then it will form the coronary ligament on the right side, and then as it extends a bit inferiorly, that coronary ligament becomes the right triangular ligament. But the importance really of this of the anterior aspect going into the posterior aspect is that posteriorly there is the IVC there. So the IVC is related to the coronary ligament, which is an extension of the falciform ligament. And then posteriorly, or really, on the visceral aspect, if we were to sort of again imagine that this was the liver, and we've just flipped it over really, and we're looking on the visceral aspect, we'll find that the divisions of the right and left again are maintained by the ligaments, which superiorly will have the ligamentum venosum, and then inferiorly will have the teres ligament. Again, these are fissures mainly, like they are fissures with the ligament extending out of the fissure or lying within those fissures. So the teres ligament is related to the quadrate lobe. It's called the quadrate lobe because it has 4 sides, while it's the ligamentum venosum is related to the caudate ligament, and the caudate ligament lies next to the IVC. That's just really a little bit on the, I suppose, the anatomy of the liver that I want to quickly cover without really saying too much about it. I've already mentioned the IVC, which is the inferior vena cava, which collects the blood from the inferior aspect of the body to return it to the heart. I also really need to mention that the liver receives oxygenated blood from the hepatic artery, which is so it is a branch of the celiac axis, which obviously gives off 3 branches: the hepatic artery, the gastroduodenal, and the splenic. To the spleen, to the stomach, and the duodenum, and to the liver, obviously. And obviously sometimes the hepatic artery can be an aberrant artery, and it can arise from the SMA, and obviously that has surgical implications in terms of say when one wanted to, if perhaps say that aberrant hepatic artery had infiltration of perhaps cancerous cells, mostly it will be like pancreatic cancer cells. So then you wouldn't really just want to dissect it, or really you wouldn't really want to resect it if it was the main blood supply to the liver. You would then have to see if it needed preservation, and what the preservation of that aberrant hepatic artery were in terms of trying to cure a cancer, which is a serious operation, obviously. So it receives its oxygenated blood from the hepatic artery, and obviously the hepatic artery is a branch of the celiac axis, and the celiac axis is a branch of the abdominal aorta. So this is the blood directly from the aorta to celiac axis to the hepatic artery into the liver, obviously branching into the arterioles. And then the liver also receives, this is about 25, shall I say 20 to 25% of blood that is received by the liver. The liver also receives, I would say, deoxygenated blood. Some people say less oxygenated blood, but then it's easier to just say deoxygenated blood from the portal vein. And obviously the portal vein arises from the inferior mesenteric vein, which merges with the splenic vein and the superior mesenteric vein to form the portal vein. Therefore, we can tell that although it's deoxygenated, it actually is bringing in red blood cells that have been degraded by the spleen, and it's also really bringing in nutrients and hormones such as insulin because if we were to remember that, the pancreas will make the hormones, and all those hormones are then secreted into the blood, this blood which eventually ends up in the portal vein. And so all those hormones and nutrients from the GI tract enter the portal vein, and then they go into the liver. And even they destroy, they degrade, these are all red blood cells that have become dysplastic and cannot pass through the channels. I know I'll discuss the spleen, but anyway, the spleen has a mechanism of selecting healthy and old blood cells that should be destroyed. So after red blood cells are made in the bone marrow, and then they go into the spleen, and then they will enter the circulation, and they usually survive for 120 days. And then after 120 days, they become a bit old, and they have to be destroyed really, or recycled. And obviously, because the red blood cell does not have a nucleus, it cannot regenerate itself. So really it has to be recycled. I'll say recycled because I say recycled because obviously, things like the hemoglobin, which obviously has globulins, which end up being amino acids, and also has heme, which ends up forming part of the bilirubin, then all recycled back into the system. So after 120 days, they are degraded in the spleen. But then I'll discuss all of this when I talk about the spleen, not the splenic vein, but then obviously that spleen. They are obviously engulfed by the resident macrophages of the spleen, and then taken to the liver via the portal vein. Obviously that is similar to that. And this is about 75 to 80% of all the liver's blood supply. So now that I've talked about the blood supply, I think I'll just look at, I've talked about the blood supply, I've talked about that it's divided into the right and left lobes. Obviously, the role of the liver, it has a massive role in the body. It makes proteins, a lot of proteins, so it can make proteins, like a lot of proteins, plasma proteins, shall I say, such as albumin. It also make acute phase proteins, which I'm not really going to go into this because I think I want to do this properly. I just wanted this to be an introduction, just to cover comprehensively the liver, and then divide it into sections of physiology and everything. Acute phase also makes globulins, the alphas, the betas. It also makes coagulation factors. It also makes opsonins, which are involved in the opsonization in the complement system. Therefore, it will make complement proteins. It will also make glucose and glycogen. It will make hormones as well, such as estrogen and testosterone, e.g. I'm not really going to cover this a lot because this is not the focus of the functional aspects, the structure of the liver. It will also make cholesterol, activate vitamin D, stage 1, shall we say, of vitamin D. It will also make IgA, I think I've mentioned, I can't remember. It will also, detoxify, detoxification. to be honest, it also makes bile. We shall say bilirubin. Bilirubin. Also recycle red blood cells. So recycle red blood cells. Okay, shall we just say it makes a lot of plasma proteins. It makes glucose and glycogen. You know, it also makes hormones and and has a lot of metabolic functions in the body. And really, IgA, importantly, is then sent back to the GI system to confer protection against pathogens. These are not all the functions of the liver. This is just, you know, briefly just to say it has a large number of functions that really, if I started talking about them now, I probably wouldn't even finish because they're so numerous. And in terms of, you know, the structural aspect, I have mentioned that the liver will receive blood from the hepatic artery. So if we were to say this is the hepatic artery there, and it will also receive blood from the portal vein. So this is the portal vein. And the two the arterial and the venule then merge together and drain into a sinusoid, which eventually drains into a central vein. And the central vein then, you know, eventually becomes, you know, the venules. Oh gosh, I can't even spell. And then obviously the right and left hepatic veins, veins eventually, and then eventually drain into the IVC. Obviously there's the common hepatic vein, and then eventually drain into the IVC. So this is, you know, the drainage system. Obviously IVC then goes back to the heart. So where this central vein and sinusoid are located in terms of the lobule is that obviously the liver is divided into lobes and it has two lobes, then it's divided into lobules where there are septals that make the divisions. So a lobule will look like a hexagon really. And the hexagon in the middle will have the central vein. So this. And at each corner of this hexagon we will have the arterial. This is a simplified way, really. This is the way that I try to understand things, by just making them simple, so that then I can build on this knowledge later on. I don't know if I should have noticed that. And then, so the arterial and the venule then drain directly into the central vein via the sinusoid. So really, if we're to do this, and again this as well, do the same. So then really we can say in the lobule, blood flows from the peripheral as in blood enters, shall we say, blood enters lobule from peripheral aspect and flows centrally to drain into the central vein. Which eventually drains into the the hepatic veins, really, and finally the IVC. So then, again, the lobule also has, I've talked about, that the liver makes bile. So the lobule also has a drainage system for the bile. And interesting enough, there is also the drainage system for the lymphatics, which I'll sort of put in as an X. So the drainage system for the bile moves from the central aspect to the peripheral. So blood will come from the central aspect to the peripheral to enter into the biliary canalici, or the biliary canal, really, which is a capillary that just drains the bile. So this is the biliary, oh god, I cannot spell biliary, all of these. And all they do is they collect bile from the central aspect, from the hepatocytes, on the hepatocytes. So biliary canal drains bile from the central aspect into the canal of Herring, which then becomes the hepatic duct, which then becomes the ductioles, and then finally the biliary duct, which then then we'll have the right and left bile ducts forming the common bile ducts, and then there will then, did I say common bile? Oh gosh. No. The right and left bile ducts are forming the hepatic duct, the common hepatic duct. This is like, from the intrahepatic duct, so it will be the right and left forming the common hepatic duct, which then joins with the cystic duct from the gallbladder. So this is the gallbladder, will give off the cystic duct, and these two will then form the common bile duct, which then join the pancreatic duct. And then the two will then drain into the, open into the second part of the duodenum, at the ampulla of Vitae. So then really, bile drains this way from the central to the peripheral. I should have used a different color just to make the point. So bile drains this way, and blood flows centrally, really. And then there is the lymphatic system as well, and the lymphatic system really collects extra plasma because sinusoids, these ones, they have fenestrations. They're not continuous. They have fenestrations, and these fenestrations allow for communication with the hepatocytes. So if the hepatocytes are there, they allow for communication with the hepatocytes, so that there is exchange of material in and out of the sinusoid. As blood is moving centrally, you know, the plasma filters out of the sinusoid and then communicates with the hepatocytes. When I say communicates with the hepatocyte, I mean perhaps it can be picking up the bilirubin, which is required. Perhaps it can be picking up you know, hormones or things like IgA, which actually go into the GI system. So that communication is required for the exchange of components. And the exchange of components between the sinusoid and the hepatocyte, these are the hepatocytes, occurs on the sinusoidal side of the hepatocyte. So if I was to take a hepatocyte, hepatocytes are specialized in the sense that they have two faces that are different. So at the did I read it twice? At the sinusoidal aspects, these are hepatocytes. We'll have microvilli to increase the surface area for exchange of stuff. And then at the biliary aspect, so this is the biliary aspects, the hepatocytes will be smooth and they won't have any microvilli. However, there is that you know, the biliary capillary there, whereby all the bile that is made in the hepatocytes enters that capillary and, you know, ends up draining out of the lobule via the what finally becomes the bile duct. Whereas in the sinusoidal aspect, so the sinusoidal is just there. We'll extend this just to make the point a little bit better. So it will have an arteriole there,